Okay, Mac, here I go. I'm going to answer these other questions for you. Start with number 15, and then I'll go back to 13. But see, the question 13 that you needed answered was the secant of, to explain why the secant of 0.08 is approximately 1 using linear approximation or differentials, why the approximation is reasonable. So, if you looked at the secant of x, this function, if you remember this from your awesome pre-calculus teacher, that graph looks like this, and there's some of it. I don't have to be that specific, but you can see that the secant of 0 is 1 right here. So if you drew a linear approximation, which means you would found the derivative of the function, derivative of secant is secant x tan x, and if you wanted to find it right at 0, it would be the secant of 0 times the tangent of 0, and the secant of 0 is 1, and the tangent of 0 is 0, so that would be 0. So in other words, the linear approximation would have a slope of 0, and anything with a slope of 0 is a horizontal line, so it would be equal to 1, because the point that it goes through is 0, 1. There's the point. With a slope of 0, it would have this equation, so L of 0.08 would be approximately 1. Excellent. Next, you said you wanted number 7. Okay, a differential. Okay, so dy and dx alone are called differentials. You know that in calculus we find the slope of the tangent line and we call it dy with respect to x. But each one of these is called separately a differential. So for 17a, it says y is equal to the tan of root t, so y of t, and it says to find the differential of this. So what you do is you say, well, dy dx is, and you find the derivative. Derivative of tan is secant squared root x, and then you use the chain rule. I'm going to rewrite, oops, look at this, I think it has an eraser. Root, what I really mean is root t, and this is, I'm going to rewrite this just so you know, that would be t to the 1/2. The chain rule says it would be 1/2 t to the negative 1/2. So dy dx is the secant squared root t over 2 square root of t. So the differential, which is the change in y, would equal the secant squared root t over 2t times the change in x. And that's the differential. You see, I just moved the dx part here, multiplied both, you can think of it like that, multiplied by both dx, so it would be this times the little change in x, and the change in x, remember, gets very small when you're taking a derivative. So that would be the answer to that one. Now we'll move on. I'm going to move this up, and number 17b says, let's change black to back. That one says y equals 1 minus v squared over 1 plus v squared, and it wants the differential there. So dy dx is, we're going to use the quotient rule, low d high, which would be negative 2v, minus high d low 2v, whoops, I just put a square in there, that's not 2v, high d low, all over low squared, and then to write it as a differential, it would equal, suppose we can multiply this through, negative 2v minus 2v cubed. Let's see, minus 2v plus 2v cubed all over 1 plus v squared, and then we put the d, oops, that should definitely say dv. Let me see. It should definitely be a dv. And there, that would be equal to the differential. I think we can simplify that a little bit, and we end up with minus 4v over 1 plus v squared dv, and that's the change in y, or the differential in y. Finally, Mac, number 19, it says to let y equal tangent of x. Find, first thing you got to do is find the differential, dy, and the second thing is evaluate dy if x is pi over 4 and dx is negative 0.1. Okay, so let's do that. I'm just going to slide this up a little bit. I'm kind of running out of space here. Okay. So, I'm going to find dy dx first. And the derivative of tan is secant squared x. So that would be that. So the differential, part A, would be secant squared x dx. There's the little change in y equals the secant squared times the little change in x. And then it said evaluate dy when x is pi over 4. So we're going to put that in there. And this really means when you square a trig to square that. And dx is negative 0.1. So the secant of pi over 4, this should be times. The secant of pi over 4 is root 2. And you need to square that and then multiply by negative 0.1. We'll just move over here. So that would be 2 times negative 0.1. So your final answer for dy would be negative 0.2. Alright, Mac, that's it. Love ya.